So, okay. So, yeah, you're right that you can have a step up, step down transformers. Let's just talk about those for a moment. So, step up. Basically, what is it stepping up? It's stepping up the voltage. So that's one thing. Just think voltage when you're thinking about stepping up, stepping down, step up, step up or down voltage. Okay, so that's what they're doing now. And when they the current does the opposite. So in other words, if I were to step up the voltage, the current would go down. I would step down the voltage. Okay, so then it's a matter of like how does that happen, and why would we want to do that? It's basically down to the fact that power is equal to current times voltage, and transformers are almost 100% efficient. So if we think about what a transformer is.
Sorry, you're being a bit glitchy.
Okay. So because the power is equal to the current times the voltage, if we think about what a transformer is, well, we don't have to think about too much what a transformer is, but we'll just say that it uses magnets, and we get a type of some electricity going in, and then we get some electricity going out. So then let's say we've got some electricity going in here, and then we've got some electricity coming out here. We've got different voltages and different currents, I1 and we've got V1. And when we multiply them together, that is equal to what the power one is, the first power. Now, the second power, the power of the electricity going out, is going to equal to the second current multiplied by the second voltage. But because we're not really losing much energy at all, or we're essentially ignoring the energy that we're losing, we can say that power 1 is actually equal to power 2. Or maybe we can say it's roughly equal to power 2. So we can just get rid of and let's just call that P then, if there's no need for the subscript anymore. So we just do that there. And then that means that I1 times V1 is equal to, or well, roughly equal to, I2 multiplied by V2. And if you
keep your power the same.
So when you can then use that and rearrange it, and you got the ratio of current I1 over I2 is actually equal to, or roughly equal to, V2 over V1. In other words, the ratio of current is the inverse of the ratio of the voltage. So when I increase the current, I'm going to decrease the voltage, or really the other way around. When I increase the voltage, I'm going to decrease the current. Okay, so that's all about why it happens. We haven't talked about much about how to make it happen, but why, when I increase the voltage, does the current go down, and so on. Now it's about why would we want to do that? Well, if I first of all, when we want to transmit the energy over a long distance, then there is a chance of energy being lost through heat, and so we could lose a lot of energy around about here. Now, if you were to decrease the current, then you actually decrease the energy loss. I won't go into the detail why that is at the moment, but by decreasing the current, you're going to decrease the energy loss, which means we're going to increase the voltage in order to decrease the current. And then when we go back down again, the downside to getting nearer to sort of residential areas, consumers and so on, then a high voltage is very dangerous. So we're going to then step down the voltage to make it safer at the other end. So we step up the voltage when we're about to transmit it over long distances, so as we decrease the current, which reduces the heat loss. And then when we get to the residential areas, we step down the voltage, because as lower voltage is safer than higher voltage.